Does not look familiar, and I just did this like 30, 40 minutes ago. Oh, 29. I was thinking 11. 29 does look familiar. All right, so what started as a square root problem has now evolved into a quadratic problem, an x squared problem. Interesting how that happens. So now we're relying completely on our semester 1 skills to factor this. What will multiply to 100 and add to negative 29? Without those skills, we can't even solve the square root equation. Oh, weird. Okay, we got answers. Negative 25 and negative 4. Why I wrote a 4, I don't know. All right, so we have x minus 25 and x minus 4 equals 0. Both of these are little mini equations using the zero product property. And we have two answers, 25 and 4. I'm always really hesitant to accept two answers on a square root equation. It's always tricky rules. My gut tells me one of these is going to be extraneous. While they're both positive, I feel like one's not going to work. Kirsten, you know which one doesn't work? Don't say it. You know it? James, you know which one doesn't work? I feel like the 25 is not going to work because it's so big. How come you went with 4? Because it's smaller? Anybody just look at it and they see it immediately. Which one doesn't work? Right. Yeah. Yep. The 4 can be seen pretty quickly after you've been practicing this and your brain's really kind of fine-tuned into it. The 4, when I put it here into the original, and maybe I should erase my work so you can see the original. When I put the 4 into the original, 4 minus 10 is a negative 6. And this square root will not be negative. So right away, the 4 can be seen as extraneous. But I'm going to unplug it in anyway so we can see why it doesn't work. So I'll check x equals 4 because it's smaller. I mean, I'm tempted just to check the smaller one first. Who wants to plug 25 in anyway? So I get negative 6 is the square root of 36. Negative 6 equals 6. I don't know. I'm so confused about every plus and minus. Okay, so this doesn't work. The left is not equal to right. I'm going to put a line through 4. 4 is considered extraneous. It came out correctly through the math process that we use to solve these, though when we plug it in, it doesn't actually work. Now I'll check 25. Sometimes neither one works, truly. So 25 minus 10 equal to the square root of 9 times 25? Carson, what's 9 times 25? 225. Oh, is it? What's the square root of 225? 15. Oh, that's how you figured that out. 25 checks out okay. 4 does not. problems were taught after the quadratics, right? Kind of a little bit more complicated, isn't it? Having to think about what works and what doesn't work. All right, moving forward to number two. Number two is a cube root. So same steps, but we're thinking of cube roots this time. This is the first time you've been assigned to do a problem with two radicals. It's all right though. I'm just gonna move this one to the other side. That's lucky that that's possible. I mean, these problems get really long and complicated if they put any more numbers in there. Two radicals. It'll take you a whole page sometimes. What's my next best step? Cube both sides. So the opposite of a cube root is a power of 3. Cancel each other out. Let's cancel. I messed this up again. There's supposed to be a 2 right here. Is everyone getting a fraction? Yeah. Let's just stay with the fraction, but there's supposed to be a 2 right here. If there was, there wouldn't be a fraction. I really want to get it right next period. The fraction works. Yeah.
I know the fraction works, but
Yeah, the
would
2.
the 2 work too?
Yeah, the 2 works, and it gives you a negative answer, which when you plug in works. That's why I picked this problem because it had a negative answer, and I wanted you to see negative work. But you forget a number, and your problem's wrecked. Oh well. 5 equals 7x plus 1. Subtract 1. 4 equals 7x. 4 over 7 equals x. So, there you go. If I had a 2 there, we wouldn't have a fraction, and the problem would just be a little bit greater. But oh well. When you check that, it does work. I already checked it. That's it for Bauer. Let's check the assignment from yesterday. So it was 23 through 30. Did I show you guys how to do 30 yesterday? Okay, so I'm gonna leave 30 here while I walk around. You end up with x to the 4th, which is a polynomial. It's a quartic polynomial. We talked about these before winter break. So you're gonna look at this just like it's a quadratic. You move over the 5x squared and the 4, set it equal to 0. You factor it as if it was a quadratic. What multiplies to 4 and adds to negative 5? Though, because it's a 4th degree polynomial, your factors, instead of just x, will be x squared. Hopefully when you see that, it looks familiar. You were tested. So if you didn't finish 30, you're finishing it right now as I walk around.
I'm not sure.
You got a plus or minus? Did they both work? No, did you use plus or minus?
I did not.
Okay, well, only the positives work. So it's kind of a catch-22. It's supposed to be, like when you solve it, you're supposed to use a plus or minus, but then when you plug in the negatives, they don't work. Ben, did you put a plus or minus in your work?
I did not.
Did you factor or square root? Yeah, but then right here, so here I would have a plus or minus, and I would have done a plus or minus, and then I would check. The negatives don't work. So technically you have it right, but you forgot one substitute here or negative.
It's worse. Both the 2 and
No, it has to be equal to 0.
You're supposed to be doing 30. You didn't finish it. Did you finish it? How come we didn't like square root? Or how come we didn't
Oh
put
yeah,
the
that's
9?
definitely not the right answer. So just one. You get 2, you get 16.
Okay, right. Two's good.
Unless it's just calculated. It does mess up the negative square. Maybe square one.
It does work. What are you talking about? Series, I put a 1 there. Got it.
Negative one is so.
What do you get? I put a 1.
That's not the square. That's it. Calculate square root. Square root.
Challenging my intelligence. I'm just.
When you did this, did you consider that these should be plus or minus? But why
You know
not?
what I did? I sat on my bed and I was like,
Pages on the other
oh,
table.
bullshit, really?
The negative actually didn't work when you plugged it in.
And then I'm gonna get on my computer.
So it could be.
Oh,
Yeah, so the negative should technically could be identified as a
I played Rocket League for a little until I updated. I had to honestly reinstall Fortnite. I'm getting better. I'm getting better.
I have still yet to see
I played chess last week. I'm getting good.
how about after?
Try to get the best I can.
I'm grinding.
We're playing a game.
We are, yeah.
Going.
I'm on the chess
I was on that last year.
Really?
I was a beginner and then.
There's 2 ways.
Okay.
My way was to divide my.
Is that just like a freshman thing?
No, it was just in Dr. B's class.
Oh, that's
we
why
did.
it's all those chess players.
Yeah.
Okay. Because we just.
Alright guys, here's 29. Here's 29. And so this was my way of doing 29. I did see someone showed me photo math, did it one different way. I can talk about that too. So dividing 2 on both sides. What I did to isolate the base and the power. Raise it to the reciprocal 2 over 1. I'm a little bit, overwhelmed by having a fraction and an exponent. But step 3 is just to use properties of exponent. So the 2 goes to the top and the 2 goes to the bottom. So it's x plus 3 squared and then the denominator is 2 squared. 2 squared is 4. I'm still annoyed that I have a fraction here. So I'm going to get rid of it by multiplying both sides by 4. And then the fraction's gone, and I can handle this like a typical quadratic. Photo math squared it the first step. They squared both sides and they turned this into a 4. And so photo math actually did it in like 2 steps less than me. Which happens sometimes. But according to our steps, isolating the base and the exponent, staying consistent with that, just divide the 2 over, raise it, and then you can clear fractions later in the problem. So of course I see a quadratic, I'm going to move everything, set it equal to 0, factor it, positive 7 and negative 5. Sorry, and then solve it, negative 7 and positive 5. The negative 7 doesn't work. This is a long one. So the first, 5 problems kind of typical. The last 3, definitely more difficult. Connor, how'd you do on 29? Yeah, you want to work on it right now? Or?
I did get the negative 35 though. So I'm proud of myself. I just I hate beef sticks. Beef sticks are disgusting. It's like a sausage and beef jerky mixed in one. It's terrible. Is this the mango one that everybody's been griping about?
See, those two.
Alright, I'll go to 28 though, I think. Didn't I show 28 in class? Okay, 28. Alright, here is 28. Add the 2x over to isolate the base and the exponent. Raise both sides to the reciprocal, 2 over 1. The main thing people made a mistake with here is that they squared the x and not the 2. So with this 2 here, when you square it, it becomes a 4. So a lot of students have a 2 here and they say it can't be factored. That's true. It's supposed to be a 4. That 4 can't be factored using the A times C method. And then a lot of people say they cannot remember the A times C method. Most of them never figured it out.
Number 1 and 2 are going to be impossible. Oh, really?
Yeah.
Oh.
There is a factoring formula.
So we need 5 paragraphs in each question.
A b squared equals a squared plus 2ab plus b.
Alright, here's your answers for the rest of them.
Gibberish.
4, no solution, 81 and 3. Did you guys get no solution for number 25?
Yes.
Okay. Alright, you guys, we are gonna do 8 more equations in class, but in the form of a game. If you get lucky and the game is completely about participation and luck, you get a free assignment pass. So somebody's gonna be grumpy at the end of this because they didn't get lucky. Does anybody want to volunteer to stand in front of the classroom? Have you volunteered? Okay.
They're going to win half.
No, you're picking numbers out. All right.